Hello and welcome to my first lesson using Camtasia, the recording software. I'm going to teach you today about how to calculate unknown angles in trigonometry when you have a right angle triangle. So I'm going to go ahead and draw one of those for you now. So with basic trigonometry we can only apply the rules of trigonometry when we have a right angle triangle. So that is, of course, a triangle which has a right angle in it. One of the angles is 90 degrees. Okay, so this one here is 90 degrees. So we know that one's 90 degrees. What we don't know is the value of the other two angles, this one and this one. So sometimes we might be asked to calculate the value of one of these angles, and we can do that if we know the length of two of the sides. So for example, we might know that this side is 8 meters and we might know that this side is 6 meters, for example, and we want to find the value of this angle here. Let's call it theta. They always use the Greek alphabet to label the angles in a triangle, so we don't confuse them with the sides of the triangle. So we're going to try and calculate the value of this unknown angle now. And what we do, the first step that we always do whenever we're dealing with right angle trigonometry is we always draw and label the triangle. Now we've done that, we've drawn it, we've labeled the values that we know, the 8 meters and the 6 meters. And we've also come up with a symbol theta for, oh, what happened there? I zoomed in. We're back. So we've drawn it and labeled it, but we can continue, we can do some more labeling here. We can label the opposite side, the adjacent side, and the hypotenuse. So we just do that with an O, which represents the opposite side. That is the side opposite the angle in question. A is the adjacent side, which is the side adjacent or next to the angle in question, and the hypotenuse is the longest side, and it's also the side which is opposite the right angle. So we know this here is the hypotenuse because it's directly opposite the right angle. It's also the longest side, but it's not always easy to tell whether it's the longest side. Sometimes it looks about the same length as one of the other sides. So we always look at the side that's opposite the right angle. Now this side here will be the adjacent side, so we put an A there because it is adjacent to the angle in question. And this side here will be O for opposite side because it's opposite the angle in question. Okay, so we've done step one, we've drawn that triangle and we've labeled it. Let's go back up there. Zoomed in quite a lot there, I don't know why. We're all good, we're back again. Okay, so we've done step one, we've drawn it and labeled it, and we're going to do step two now. Obviously if you practice this you'll get faster and faster at it. We're going really nice and slow today for this first example. Step two is to choose the correct trigonometric, it's a nice big long word that you can just shorten to trig if you like, ratio. Now we know a little mnemonic strategy is SO, which is sine, ca, which is tan, cos, and toa, which is tan. Okay, and that tells us which sides sine, cos, and tan are associated with. So in this particular one, let's have a look at what values we've got. We know the opposite side and the adjacent side. Okay, we don't know the hypotenuse, so we're not going to use the ratios that have hypotenuse in them, that have h in them. So sine has an h in it, so we're not going to use that. Well, let's choose the right pen. That one, we're not going to use that one because it's got an h in it. We're not going to use that one because it's got an h in it. We're going to use tan because it involves O and A, and those are the two sides we know. So we've done step two, and what we do is we write it. We write, no, not an S, we're going to write a T for tan of the angle, tan of theta, is equal to the opposite side divided by the adjacent side. and that's saying that the tan of this particular angle is equal to the ratio of O to A. Okay, so if A is twice as big as O, then it'll be a 1/2 ratio. Okay, step 3, we've got a formula now, we've got an equation, so we're just going to go ahead and substitute like you always do in maths. As soon as you've got an equation, you can substitute it and then you can rearrange it. So use a bit of algebra to rearrange it and make it look the way that you want it to look. And we can actually do rearranging first and then substituting as well if you want to. That's up to you. Okay, if we're just subbing in simple numbers, I like to just sub in first. So we're going to write tan theta. Now I can't substitute anything for theta because that's the value I don't know. That's the value I'm trying to work out. Okay, so but we can write what O is. O is, as you can see there, 6 meters, so we're going to write 6. We don't need to write O anymore because we can write 6, we know the value of it. And A, the adjacent side, is 8. So the tan ratio is a 6:8 ratio. Now we can simplify that if we want to a 3/4 ratio. But it'll still work even if you don't do that. So now we need to get rid of this tan. So step 4 is to press the shift or the inverse function button on your calculator, and what that does is it tells us the inverse of the tan ratio, because we know the tan ratio is 6/8. So in your calculator on our books we're going to write theta equals the inverse tan. So you put a little tan, a little -1, and then you put a bracket and you write 6/8 or 3/4. You'll get the same answer either way. Okay, so we're going to press shift tan bracket 6 divided by 8 close bracket and then equals or the enter button, and you'll have your answer. Okay, so we're going to calculate the inverse tan of 6/8. Now on my little screen calculator here it's a slightly different order. I actually have to type in bracket 3/4. I probably don't really need the bracket, so it's 0.75, and then I hit inverse or shift and then tan, and the answer is right there for you. It's 36.86989. So let's write that in. 36.86989 degrees. We can round that up to fewer decimal places if we want. We can convert it to degrees, minutes, seconds if we want to, but we'll leave that for another lesson, I think. So there you have it. There is a summary of how to calculate unknown angles in a right-angled triangle. So just a quick summary of what we did. We drew it, we labeled it, we identified the opposite side, the adjacent side, and the hypotenuse, and then we chose the correct trigonometric ratio, either sine, cosine, or tan, and in this case it was tan. We wrote down the equation, tan theta equals opposite over adjacent. Then we substituted in those values which we knew, which was 6 and 8, and then we used our calculator. So we didn't touch our calculator until right at that last step, right to step 4. We're just going to press shift, tan, bracket 6 divided by 8 close bracket equals, and we get the answer 36.86989 degrees. Hope you enjoyed, and we'll see you next time.